Hello, everyone. Welcome back. Hope you all had a good weekend. Nice to see you all here. We are moving into a very brief science unit. Today we have Sarah Aciego, who I'm going to introduce in a moment. And yeah, we'll have a couple announcements at the end of class. And then, as usual, the response form, which captures your attendance. So I just want to remind you that if you don't fill it out in class, then we don't really know if you're here. If you don't have something to fill it out with, either you can maybe get on someone's laptop quickly or just come make sure we know you're here, because we can write down your name manually and be sort of old media about it. But we just want to make sure that we are taking account of everyone in the room. But if you don't have a chance to fill it out here, we do usually reopen the link, and so we'd love to get your response at a later point too. So. Yeah, so today we, as I said, we have Sarah Aciego, who is an assistant professor in the Department of Earth and Environmental Sciences, and her focus is on Glaciochemistry and Isotope Geochemistry, and that's the research group that she's part of within Earth and Environmental. She received her Ph.D. in Geology from UC Berkeley in 2006. And her research, as I have very broadly translated it, so she can correct me if I'm leaving out important things, focuses on studying isotopic tracers of ice and dust as a means of tracking changes in polar, temperate, and tropical climates. And an isotope is something in chemistry that many of you know lots about, I'm sure, more than I do, I'm afraid. But we're here to learn. Sarah travels regularly to far-flung locations, which I imagine are even colder than Michigan right now, places like Antarctica and Greenland, where she takes ice samples and other kinds of measurements for her research. And she was recently awarded a prestigious Packard Fellowship for Science and Engineering for, and I'm quoting here, pioneering a new chemical method to determine the age of dust trapped in glacial ice in Antarctica, unquote, which will contribute to data that will allow for a much broader and more comprehensive picture of climate change. And then finally, one more quote about her from this U of M Record article about the fellowship. It says here, an outdoor enthusiast, Aciego says she switched from engineering to geology in college after realizing she wanted to, quote, do science in the sun, rain, hike around, and get dirty, unquote. So lots of fun in earth and environmental sciences, getting outside of the lab. So with that, please welcome Sarah Aciego.
Oh, yeah, we can hear. A little higher. Okay. Maybe a little higher this way. There we go. Okay, so so I'm trying to balance a little bit on all the different background that you guys might have in terms of science and new media, and I think new media is something that I don't really understand that well still. So what I thought I would do would be to talk a little bit about what I do, and then why it's important for me to communicate to a bunch of different audiences in a way that is accessible to these different audiences. So my group, my research group, as Naomi said, we study climate change, and we study climate in a bunch of different areas, and we use ice. So we spend a lot of time in very cold places, and in the last 3 years we spent 4 months in the Canadian Rockies, 4 to 5 months in the Alaska Juneau ice fields, 2 months in Greenland, and we just came back from Antarctica about 4 weeks ago, where we spent 8 weeks camping on a glacier. So we are very interested in the records of climate change that we can find in ice from drilling, and that's something that we can talk about more in a minute. And we also very interested in how glaciers are changing due to current climate change. So glaciers are glaciers and ice sheets are about 97% of the fresh water on Earth. So all the lakes around here, that's not much compared to what's actually trapped in this ice. And so we care a lot about what's going on with this fresh water. There are also alpine glaciers and temperate glaciers in the western United States, western Canada, and Alaska, South America. They're used as reservoirs for water, for drinking water. that is then used for, well, drinking water, but as well for things like agriculture and irrigation. And so we're trying to figure out how these glaciers, which have, for the last, 10,000 years have been utilized pretty significantly by humans and our development, and how that might change pretty quickly in the next couple of years. So, so one thing that you guys may or may not be aware of is that oftentimes those of us that are studying climate change, we are frequently attacked for, how do I put this politely, but because people think we're making it up, right? Climate change isn't real. CO2 in the atmosphere is not causing global warming. You can't know that in 100 years all the glaciers are going to be gone, that there's going to be 7 meters of sea level rise. And as you can imagine, because if you're constantly being told what you're doing is wrong, you have to somehow communicate a little bit better what you're actually doing, and make it accessible to basically everyone. And so in a research field, in my kind of research field in the natural sciences, we have to worry about a bunch of different audiences, and those audiences are, of course, the general public, which I'll come to kind of in the middle of this presentation. But also, I worry about the employment of my students. So I have 6 graduate students that are pursuing PhDs or master's degrees. And the purpose of that eventually is that they will also continue in science, either in industry or in like government agencies, a national lab, or they might continue in academia themselves. And so my role as their mentor is to make sure that once they graduate, they can get employed. And so we have to communicate how good of scientists they are, as well as how good of a scientist I am. I'm pretty good. I was quoted in the newspaper, and I've been featured in all these different places. But I have a job. They need a job. So we have to communicate somehow that they're really good scientists, and that eventually when they graduate, they would be, somebody should hire them, okay? And then I also have to communicate, so we, just to give you a ballpark figure, to run my lab and do the research that we do, we have to bring in about $500,000 to $750,000 a year. So I'm a small business, and that small business means that I'm getting money from government agencies and sometimes private foundations to pursue this research, and I need to show them that we're using this money well, okay? And I need to do it in a way that is accessible to them, as well as to people that actually review our proposals. So we write really big proposals to bring this money in, and the reviewers of those proposals then have to say, oh, they're capable of doing this. So I need to be able to show them in as many ways as possible that we're doing good work. So yes, and then the last thing is we can't do this by ourselves. So me by myself can't just go to the Juneau ice fields and do all the logistics of getting onto a glacier, of camping, of having permits, and all of that. You just can't do it by yourself. So we rely on a network of different polar scientists who have had experience in these places before. And of course, once we experience something new, we try and share it with other groups that are trying to do research in these areas. So what I thought I would do would be that for kind of your first exercise, since everybody has computers, if you could go to my group's website.
And if you don't have a computer,
Maybe you can share.
sit next to someone who does. That would be great.
I certainly can. Maybe. That's what. Can we turn off maybe all the lights for just a little bit? Maybe. It's so weird. So hopefully you guys can, if you go to the website, you'll see it on your own screen, since hopefully you guys will go through this in the next 5 minutes, and then we can talk about what's in here.
Got
can go back to. Usually they have like a set for.
Oh, that's right. That would be really convenient.
Where it just sets the lights, yeah. Are we there? Okay. So I'll bring it back up. And what I was hoping that you guys could do to kind of think about how, it's funny calling a web page new media. I actually did use the intranet when I was your age, so it's not so new anymore. But it is an effective way of communicating with people because they can Google you and then this comes up, and this is better than Facebook. I don't want people looking at my Facebook page about science. So so you should all be here. Can you tell me why I might have these particular categories as things that we can look through? So we have people, projects, facilities, publication, education, photos, and links. So yeah, go ahead.
Well, if you're a student, you want to be able to find people who are researchers in a field that you're interested in, and then find like the projects that you'd also be interested in and see where they line up.
Right, exactly. So this was actually the first reason that I built this webpage is, as it turns out, getting good graduate students is incredibly competitive. So I compete against people that I went to graduate school with for the best students. And so the first thing I did before I even got here is I had this webpage made for me before I actually came to Michigan. And the projects can be, I try and pull people in. Right? I say, okay, I do really amazing stuff. So my projects page have pictures about what we're doing in here. And so you guys could click on any one of these. This is where we just were. Okay, so this is a picture from the helicopter on our way into our field site. And so this is great for if I just want to be advertised how great our field seasons are, and that's all the amazing things that we're going to do. Why do I have a whole bunch of text about the science? What do you think? I'm going to randomly pick people soon. Yeah. Yeah, exactly. So I try, actually, so this text right here, if you guys spent the time, I won't make you read it out loud or anything like that, but if you wanted to read it, you would find that it's actually, I try and make it as accessible as possible. So I don't put a lot of technical details about the project in here. So I'll talk about the last glacial maximum, so the time period when it was the most cold. I'll talk about time periods and years instead of assigning them a name, like we might say the Holocene or something like that. I say 6,000 years ago. And then we talk about what the implications are for the research. So potential implications for predicting climate shifts in coastal regions that will be experienced, that have been experiencing or will be experiencing a decrease in, of sea ice. And so the reason that I have a really broad summary is that I'm trying to both communicate with potential students who are, may not be familiar with all the different aspects of our work, but also so that if I have people that are potential reviewers, they can see what we're doing without the details. And then the other reason that I do this is, what do you think about the person that gave me $2 million to do this project? They probably want to see that I'm doing something with this project, right? And on top of that, I give them credit. So down here at the bottom, I'll say, this project is part of my student's thesis, Sarah Aaron's thesis, and it's funded by the National Science Foundation under this particular program, Antarctic Glaciology. Because this way, the program manager, if she wants to talk about what a great scientist I am and all the great people that are working on the project, she can point people to this webpage where she can say, this is my scientist, she's in the Antarctic Glaciology program. So, so this is a bit of a sales pitch. And then I also, because what I said earlier about how we need to maintain our networks, I also talk about the people that we collaborate with. So Paolo Gabrielli from the Bird Polar Research Center at Ohio State, and Barbara Diamanti, who's at the University of Milan in Italy. So, so it's a way of reaching a whole bunch of different audiences and kind of advertising the projects that we do. Okay, so what about if we go to people? So one thing I like to do in this on this webpage is, of course, it's me, and I'm the big boss. So I would put myself at the bottom, but then otherwise I think my graduate students were in charge. So I put myself at the top, just I'm in charge. But then I have all my graduate students, and if you scroll down to the bottom of the page, you'll see that I have all my graduate students, and I also have all the undergraduates that work for me. And this is something that I do for them, similar to what I do for my graduate students. So why might I highlight the undergraduates that are working for me? In the back. Yeah. Yeah, why do I highlight the undergraduates that work for me? Yeah, so I give them credit, yeah. What might be another reason? Yeah, so it's a recruitment tool for undergrads, so they can look and see, who's working for me now. I also highlight who the alumni are. So I've had a couple students that have graduated or have decided to become nuclear engineers instead of earth scientists. And then one student still hasn't given me your picture. But what is another reason? So it's a recruitment tool, and then what might it be doing for them? Yeah. Yeah, so I'm giving recognition, yeah. What else can I be doing for them? Yes, exactly. It makes them more competitive for graduate school. Because this is a, what's it called, dynamically linked web page, if someone does a search for them on Google, this shows up. And it shows the group that they're working in. And then the whole web page then is an advertisement for them and the skills that they have, right? So a lot of the undergrads that work for me or have worked for me in the past, they get to go and do field work with us. And so they have a resume that includes field work. And then the other thing that's on my web page, if you go back up to the top and link over, is the really technical facilities page that has has basically everything that we're capable of doing in my laboratory. So in addition to the field work, we do a lot of really technical things with mass spectrometers and nanobalances. And I talk about the kinds of measurements that we're capable of doing, and as well as the kind of freezer space we have for dealing with large amounts of ice core. So why might that be important for these undergrads that I'm highlighting in terms of job prospects? Yeah. Yeah, exactly. So, sometimes you put something on a CV, and when I'm reading a CV, I just have to trust that they kind of know what they're doing, or go with whatever the letter says. But this way it shows, without me having to put everything in a letter, it shows that even if they don't have experience working on a particular part of the project, they're completely familiar with everything that's going on in the lab. So they're capable of coming to a new situation, going in as graduate students later, they're capable of going into a new lab, learning new skills, and have been in this kind of very clean, very technical environment, and so will be good, good graduate students later on. Okay, so this is kind of how I use my website, and I have pictures in here, of the lab. I have pictures of field seasons. So this is, us in the lab, and this is also advertising for our NSF program managers and NASA program managers, as well as potential reviewers. I also put up here publications, because we like to highlight things that have come out recently in terms of academic papers. And then the links page, oops. This is another place where we try and give credit to people that we're collaborating with, or organizations that are supporting us that are not giving us money but are giving us some kind of access, or in the case of a company like Mountain Hardware, they support us by giving us equipment. So they provide us jackets minus 40 degree down bags for camping, that kind of stuff. So it's like Naomi said, this is not as cold as other places I've been in the last 2 months. So all these, so I even highlight my website designer, because all of these people, having a network is really important, and so giving credit where credit is due is also really important. Okay, so, but on the very first index page, we also highlight our blog. So because we spend a lot of time in the field and it's hard for us to update the web page kind of dynamically, we have to use a blog because it's just too hard for me to open Dreamweaver every time we want to add some pictures to the web page. And so we have the link to the blog, and if you guys could click on that. So this is a different kind of new media, still not new. I think I was blogging when I was in graduate school, if not as an undergrad. But it is really important because this is, do you think that my mom can read, well, you don't know anything about my mom. My mom, who's an English major and does not even know what an isotope is, do you think that she would enjoy my webpage very much? Probably not, okay? So I try and think about people like my mom or my grandma or my sister who's a PTA and thinks I'm crazy for going to cold places when we write for the blog. So we try and make things really about the field work. And so in the last, my student Yue just got to Norway 2 days ago, and she's actually collecting clams in the North Atlantic in Norway. So right now it's also very cold there. This picture is them collecting these clams. And the clams are going to be used for a study on how ocean acidification is affecting carbonate organisms. So organisms that actually precipitate carbonate out of seawater. And so it's just like, I don't know what a good example is for you guys. Do you guys know what ocean acidification is? I mean, it's easy to think about melting ice and sea level rise. What do we have here? Ocean acidification. Yeah, so it's correlated with temperature, but does anyone know why the pH is actually changing? Is it thermal expansion or something? No, it's not thermal expansion. What happens if you drink too much Coca-Cola? Even Diet Coke. What happens to your teeth? You know, guys, haven't ever seen these experiments? What kind of science teachers did you have in high school? They do what? They rot at the root. Yeah, exactly. Because if you put a whole bunch of CO2 into a liquid, it makes it very acidic. So the pH of Coca-Cola is something like a pH of 3. Okay? So a low pH is 1. Normal neutral pH is 7. Okay, so the water that you drink out of the tap is about a pH of 7.5 to 8. Okay, so you put some CO2 into a liquid, water, and basically what happens is it becomes very acidic. And so, so the reason I said temperature and ocean acidification, they're correlated, but they're not. The temperature is not the cause of the increase in the decrease in the pH. It's not the cause for the ocean acidification. The cause of the ocean acidification is that you have higher amounts of CO2 in the atmosphere. And so higher amounts of CO2 in the atmosphere are doing two things. They're causing temperature to go up, but they're also causing the oceans to become more acidic. And this is very well known over the last 4 billion years of Earth history, that you put CO2 into the atmosphere, and CO2 likes to dissolve in water. That's why we can have Coke that is all fizzy, is because you can actually push a whole bunch of CO2 into water. So what we're looking at is clams essentially are made out of the same thing as the roots of our teeth. They're made out of carbonate. They're actually an aragonite structure. So clams are a good example. Coral, if you guys have been snorkeling or scuba diving, you may have seen this phenomenon where you have a lot of corals that are dying right now, and that's because of this ocean acidification. Basically anything that has a shell, so shrimp, lobster, all of these organisms, they're starting to actually dissolve. And in order to keep themselves from dissolving, they try and work a little bit harder to precipitate more and work a little bit harder. And so it means that they actually get smaller and smaller over time. So instead of getting bigger, they are stunted. And so one of the things that we're interested in is organisms that are affected by this ocean acidification in places where it is the most dramatic. And one thing that you guys probably know right away is how is the temperature, how much CO2 can you get into a bottle of Coke when it's hot versus cold? Yeah, exactly. So if you have, you take a can of Coke out of the fridge, you open it up, it doesn't fizz like crazy. Take a can of Coke out of the fridge, you let it warm up. On a hot summer day, you open it up and it's like explodes, right? So this is the same phenomenon. So what happens is that in the low latitudes, you actually don't get very much CO2 dissolved in water. So around the equator, the pH is actually still quite high because you can't dissolve as much CO2 in the water. But in the high latitudes, we can actually dissolve a bunch of CO2 in the water, and so the pH is actually much lower in the North Atlantic and South Pacific than it is at the equator. So that's a long way of getting to why we're here, which is that we're interested in how these clams in the North Atlantic, which is off the very north coast of Norway, and UA actually puts what the latitude is here at the top. So she is at 71 degrees north. It's pretty high latitude. It is cold there right now, and she did tell me that they've been able to see the northern lights, which is, I was kind of jealous of that. Yeah, so the idea is that we use the blog to communicate about the places that we go. And one of the things that we do is, I just gave you this long, complicated science expedition. I didn't put that on here. I say, this, we're interested in clams. This is why we're there. But we do try and bring things closer to home. So I have this long post from December about how we drill in Antarctica. And you can click on the pictures and see it's quite beautiful. It's really hard work. We have to pull the drill around because we can't use anything that's automated here because the oil is a contaminant for people that are measuring CO2 and methane. And we had a bunch of posts like this. So we had posts about drilling. This is really hard work. We got our hands cut. Our knees are bruised. It's really hard down here. We had a post about weather. This day that we had this storm come in and it was a complete whiteout. And then we just thought, okay, I think people are tired of all the really pretty scenic pictures, so we had a post about food. Because as it turns out, when you're camping for 2 or 3 months, all you think about every single day is food. You get up in the morning, you eat breakfast, and then we're drilling and we're like, what are we having for dinner? And we talk about what we're having for dinner for about 8 hours. And so this is our post about what we eat for dinner, and what we eat every day. Because so people think it's really cold. How do you survive it? And we burn about 8,000 to 9,000 calories a day. No joke, because it's minus 20 to minus 40 degrees, and your body's just, even if you've got lots of warm clothes on, your body's just working hard to keep up with that. And we're sleeping in it. We're camped out in these conditions. So we change clothes sometimes in our sleeping bag, but you can't put your boots on inside your sleeping bag. So you put your feet in your boots, and that's got to warm up a good, 70, 80 degrees before you're warm. And so we eat a lot, and we eat a lot of chocolate. So we have this is our list of everything hot that we eat. So hot chocolate, hot Tang, hot coffee. Coffee with condensed milk. We probably drank 3 or 4 cans of condensed milk every 3 or 4 days, so a can a day. And then for dinner, we ate things fried everything, fried in butter, pretty much. If we weren't eating almost a pound of butter every other day, we weren't getting enough calories. So, and this is fairly common for Arctic explorers. If you guys ever read any of the accounts of the first expeditions across the North Pole, you'll find that their packing cases, it's like 50% butter, because it's the easiest way to get a lot of calories into you every day. And it doesn't freeze as hard as other things, so you can warm it up and kind of put it on stuff. But we just fry things. So we fry steak in butter. We fry halibut in butter. We fry pork in butter. And then we really like chilies, so it's usually steak, a stick of butter, and 2 cans of chilies. So we decided we'd do a post about that because nobody believes you if you say that. So that's what we have. This is what we eat. And then the other thing that's often quite sad that people don't realize is, of course, we have no access to any fresh vegetables or fresh fruit at all. So except when we have a helicopter come to visit us and somebody has very kindly put in some vegetables. And so this was like, we had a really good day this day when we had a pepper and a tomato and 3 tangerines come in a box for us. And that was a pretty exciting day. So in terms of new media, if I'm going to go back to the theme, this is our way of telling people what it's really like. Okay, so it's not just this is the science. It's all very esoteric. We're measuring isotopes and dust and all this stuff, but really it's about the exploration. The reason that we're doing this work is because we care about this environment, and these are the things that we have to go through in order to collect these samples. Yeah. So, and you guys, I mean, I don't know if you're interested in this kind of stuff or not. This is our trip, this is a lot of stuff from Antarctica. But we also, this summer, we were in Greenland. And so this is one of the helicopter trips that we took up into the fjords in Nuuk, above the, so this fuzziness right here, this is the clouds. So we're a couple thousand feet above the clouds that are in the fjords. So we try and post both pretty pictures as well as the funny pictures, just so people can see that it's, we're doing all kinds of different stuff. Does anyone have any questions about this? You don't have to ask me questions about new media. It can be anything to do with field work too. Yeah? It doesn't seem warm. I don't know how to put this. So I thought it was going to be warmer when I landed, because in the past when I've come back from Antarctica, it's always been warmer. But the day that I landed in Detroit was the day the second polar vortex landed. And so I was like the last flight that was allowed to land, and it was -20. And I had to share the car with 5 other people because they couldn't get any more cars out. And all I could think was about how I haven't been to my house in 4 months, and I can't remember if I hired somebody to plow my driveway. And there was like 3 feet of snow, and I was just thinking I had this horrible feeling like I was going to get out and I would just not even be able to get into my house. But I had actually remembered to hire someone to plow my driveway. But I hadn't hired them to dig out my car, and I don't have a garage. And so the driveway was plowed, but my truck, I have a giant truck for all the field work, it looked like an igloo. It had 3 feet of snow all the way around. So I was like, oh, it's no problem. I'll just deal with that in the morning, and then I'll go to this. I have no food because I've been gone for 5 months. I'll just deal with all this in the morning. And I went to bed, and I got up the next morning, and I just put on all of my gear from Antarctica. It was awesome. I was just like, well, I haven't unpacked yet. I'll just pull that out, long johns, fleece, the parka, the goggles. And I went out, and I dug out the car, and I thought I was being so clever. And I got in the car, and I went to start it. And of course, it's been 5 months sitting there and 2 polar vortexes, and it did not start. But I mean, to be honest, I was prepared for the cold. So when I got back, I've just been wearing the same things I had been wearing for the previous 2 months. Some days I wish it was a little bit warmer, but it's not. It doesn't feel particularly cold, no. Yeah. Anyone else? No. Over here. Yeah, sorry.
Have you thought about getting like GoPros?
Yeah, actually, this is one of the things that we're going to be doing for our next field expedition. What's been hard with GoPros is that they don't take real videos. They basically do stop action, and so it can. We were trying to figure out a workaround on that before we went into the field, because one of the things that we'd really like to have is more videos of what we're doing, because sometimes in pictures you get this feeling that it's always perfect because we post the pictures where things are in focus, right? Because that's we were able to stay still long enough for it all to work. But there are a couple times in these storms where it's just like we can't even stand up. You know, we're like kind of holding on to things, and like our feet are flying out from under us because the winds are so strong. And you just wish that you had a video of that, but you know, I'm not going to like pull it out and set the video mode and then hit stop and go. And so we've been trying to figure out a way to basically do more videos and have those on the website for sure. Yeah. And the other thing that we'd really like to do with GoPros is there's a lot of places that we want to go. So actually on here, this project that we've been working on in this location, yeah, here we go. So we study meltwater. I'm really sorry about the screen. Maybe on your screens if you guys go click on this. So this particular glacier, I'll go back for a second. This particular glacier in southern Greenland is this glacier right here. Is about 150 miles long and about 5 miles wide. And that river that's coming out of it is about 5 times the size of the Huron. And so this channel, this channel is about 30 feet deep right here that we're standing next to right here. And so, and you walk into this cave and you just hear this water coming through, and you hear the glacier moving above you. It like creaks and groans because there's so much water there. It's actually lifting up about 500 meters of ice above it. And so it would be really awesome to take some videos of that inside with the sound too. But I'm tough, but I'm not a diver, and I've never been, I can handle myself in crampons, but I'm not an ice climber, like I'm not going to go to an ice climbing competition. So I think that I would like to do more things that were interactive with people that didn't require me to be like super, super tough. Like I want to just be able to walk up there and be able to look inside. So yeah, GoPro cameras are definitely one of the things that we want to do. Yeah. Anyone else about this? Okay, now comes the hard part of the class. Okay, so I'm going to switch gears a little bit, and that is I wanted to talk about, so basically what we've talked about is only how I communicate with basically my, people that give me money, people that are going to tell people to give me money, my students, and then general audience. So I'm trying to communicate what we're doing to my mom and everyone else's mom. But it turns out the most important thing for us in order to continue to do this work is to actually communicate very well with our peers. So people at other institutions through the academic publication process. Because it's one thing to be able to put up here that we have some results and say, oh, we collected these samples and the water had this pH, but you actually need to go through a review process for people to look at your data quality, to look at how you interpret your data, and then say, okay, we believe you, and that this data should be out there as proof of some kind of past climate change, or nutrient fluxes that are going into ecosystems, or something about perhaps ocean acidification. And so when we communicate through academic publications, I don't know how much you guys know about this. So I gave Naomi a paper for you guys and then realized afterwards that it was probably like, woo. And the point wasn't that you were supposed to read it and understand it. The point was to look and see what the format was. So this is how scientists talk to each other, and we talk to each other in the most opaque language as possible. And so that paper, if you had seen just that final version, you could think of it as being kind of a traditionally published paper. And this is how we've been doing things for 350 years. Einstein published E equals mc squared in that same kind of format. He had a paper, it's only 5 pages, but he had a paper in which he proposed a variety of quantum theories. And when we publish these academic publications in this very traditional sense, we have a traditional peer review process. And that traditional peer review process is that we'll submit a paper for publication, and we'll submit it to one editor. So we'll send it into an editor, and then he will assign 3 to 5 anonymous reviewers. And those anonymous reviewers are people that, this editor is the editor of Big Journal. He knows basically everyone in your field, and he picks people who may or may not like you. For one, he may pick people that he knows that you are constantly battling with over science, or it could be people that he knows like you. But these 3 anonymous reviewers have to have no conflict of interest. So it can't be anybody that you've ever published with before. It can't be anybody that you have funding with, and it can't be your brother or your sister or your mom or anything like that. So we have 3 anonymous reviewers. The editor sends them out, and we call it a closed review. Okay, so the paper will go out, and do you guys have experience with the peer review process? I mean, it seems like you should, because this is something that's pretty common at Michigan now, that you will read each other's papers, right, in class, right? But you kind of know who it is, right? Like you'll give it to the next person, and you'll give it to the person next to you, and you guys will comment on it, and that seems pretty free form. And sometimes you might be uncomfortable and that maybe you didn't write it as well as you should have. You're up really late at night, and there are more spelling mistakes in there than you intended. But in this case, we try for perfection, and it goes out to 3 people that you have no idea who they are. And then those reviews will go to the editor, and the editor will make a decision about whether or not it will get published based on those 3 reviews. Okay? Generally speaking, the reviews that you get in this traditional peer review process are, if not kind, at least polite. So nobody says, you're an idiot, you don't know what you're talking about. There's no inflammatory comments like that. They'll usually say, we think that Professor Aciego perhaps misinterpreted her data and needs to go back to equation y equals mx plus b and figure out the correct intercept. Okay, so similar kind of opaque language that we use in our paper. That has, there are a couple, we'll say, recently it seems like there has been a couple issues with this in the sense that, at least in climate change research, there's more of this feeling like we're faking our data, right? This is all this climate gate that was a couple years ago, that somehow people are making up their data, and this whole peer review process is a scam, that editors are sending these papers out to people that know each other and don't have a conflict of interest. And I would say there's probably no other field in science who has to battle this kind of misconception. And so the way that one particular journal decided to attack this was to use a different, an additional kind of review, and it's called the Open Access Open Review. And this is the journal, The Climate of the Past. And so they have 3 assigned reviewers. This editor assigns 3 reviewers, or asks 3 reviewers to review this paper. And then instead of it being closed, he then posts, the journal then posts this submitted manuscript online. As it is, without any changes. This is what you've submitted goes online, and they call it an open review. So anybody can go in. You guys, right now, you could go in and make some comments, and I invite you to do that. You're welcome to do that. If you don't understand something, you're allowed to make comments. So if you guys could get here to this webpage, climateofthepast.net, you will see that this is right there on their front page. It's just the front page of the journal, but we'll get to the link in a minute. Okay, so this is the front page of the journal. It basically talks about all the things that they're interested in having submissions in, which is, perhaps not so interesting. But this is the reason that they have this 2-stage publication process, which is, let's see if I can zoom in. Okay, so they want to foster scientific discussion. They want to enhance the effectiveness and transparency of scientific quality assurance, enable rapid publication, and make scientific publications more freely accessible. Okay, so I didn't talk about this fourth point. So we might have, you could understand probably why fostering scientific discussion amongst, more than 3 reviewers might be interesting. But why is it important that we make scientific publications freely accessible if we're talking about, say, transparency? Does anybody know one of the really great things about U of M, probably not such a fantastic thing about some much, much smaller schools? Have you guys had to download papers, not given to you on C-Tools yet? Anybody? Had to do a Web of Science or journal search? Yeah? So what do you have to do in order to get access to that journal?
Well, you can sign into the U of M library to get access to the
Yeah, so you sign in through the U of M library. Do you know how much it costs for a subscription to one of these journals? Hundreds, thousands. I think the journal Science, the subscription cost is something like $100,000 a year. Okay? So when we talk about really important papers in climate change, it turns out that they're not accessible to the layperson. And they can pay $40 if they want to download it. But if you just wanted to know something about climate change, you don't need to know all the details, but these are papers that we're talking about in the news, we're talking about, actively fighting about in the news, and most people don't have access, okay? So one of the reasons that this journal is doing things this way is to not only make things accessible early in the process so people can talk about it and ask questions about different papers, but also at the end that paper is then freely available. So open access journals. This is definitely something very, very new, probably in the last 5 years or so. Okay, so back to this open discussion. Let me close this again. Okay, so also not the link that I sent you, but this one is a good one to go to. It is climatepass.discuss.net, or maybe if you guys click on the other one that I sent, that would be. Let's see. So if you guys went to, yeah, so, okay. So if you go to online library CPD on the left, and then there's two links that I'd like us to go through. One is papers and open discussion. If you click on that on the left, you'll see these are all the papers. Oh. And I'm not mirrored, so one second. Sorry about that. Go away. Okay. Okay. So right here on this papers and open discussion, this shows, this is today, right? So somebody submitted a paper today, and it's already online. Okay, so this is essentially first draft online, up for first draft. Well, final draft going to the journal, but first draft for everybody to look at. And so it has been assigned an editor, which is why it's here, right? Because the editor needs to decide to actually upload it. And then what you have is the paper itself. You have supplementary data. So generally nowadays in publications, nobody shows all of their data in the paper anymore. It's always online because we're generating thousands and thousands of data points, and no one wants to read a table that's thousands and thousands of lines long in a PDF. So we have supplementary data, and then we have the interactive discussion. So let's choose one that actually has a comment on it. Down here. These are the open ones, so here we go. Okay, so this paper, I can open it up and we'll see if you guys can actually see what you need to see in here. Okay, so this is actually really different than format than what you guys saw in the paper that was posted to C-Tools, right? So what you saw in C-Tools was this very kind of formal PDF with the journal article, and this is definitely more, I guess we'll say, interactive, right? So this is interactive publications now, and so you can go backwards and forwards. You can go directly to the tables or the figures in this case, and then all over the place wherever you want in this particular paper. And you notice it has here, you can go to the interactive discussion at the bottom, okay? So at this point, this paper is not accepted for full publication yet, but it is under discussion. And so there are a bunch of comments here. And what you'll have is, no. This one. So right now, we only have the comment from the anonymous, one of the anonymous reviewers. And what you'll see is that the anonymous reviewer is still kind of following the format of a normal review. So he's being polite. He's like, the usefulness is related to the quality of the, he's using polite language, okay? So this is pretty common for the referees. And part of that is because these anonymous referees, they're only anonymous to the world, but not to the editor, right? So the editor knows who this anonymous referee is. So if they're rude, they're probably not going to be asked to submit a paper or do another review in the future. Okay, so that is, this is kind of this is the open part of it. And, but this is not the most interesting of these papers because, let me get back here. Let's go to the one that I actually asked you guys to look at. So this is, at this point, these papers have either been accepted or rejected, okay? So they're closed. So it says here, final revised paper, okay? So if it says final revised paper, that means that it's done, there's no more discussion. I think I chose, I don't remember which one it was. Which one did I choose?
Modeling the consequences on labor.
Okay. Or let's go to this one, because I think this one is more interesting. The comments in this one are more interesting. Okay. Okay, so here we have, okay, so this is one of those examples of when you say something, have something potentially inflammatory in your title, or what might be perceived as inflammatory if you do not accept climate change is happening, that it can basically turn into what you guys might know as a flame war. Okay, so we have here millennial temperature reconstruction, intercomparison, and evaluation. So the idea is this is somebody that's looking at temperature changes over the last 1,000 years, and all of a sudden we have this whole chain that's talking about the transparency of their data. And at this point, that you'll see, do you see, it's not so polite anymore, or it is a little bit more inflammatory. We have, I was astounded, however, that you would single him out for his comment on this matter when your co-authors have been much worse transgressors. So-and-so has never identified the sites in this other paper. There's not enough transparency in their data. And on top of that, it's clearly a long-running debate, because if you look at how it's not anonymous, right? These are straight up guys basically having it out on the web about science. So perhaps, for better or for worse, right? If it's anonymous, then you don't know who you're fighting with. If it's not anonymous, you're having this open argument on the internet that will probably spill over into your students, because if your students know you're having arguments with people, then they're all of a sudden, your students become involved in, in whatever you're doing, and they start having arguments with this other guy's students, and you go to meetings and people are shouting at each other in kind of an open forum. So sometimes, yeah, sometimes this works, and sometimes it is an opportunity for a lot of vitriol. Do you guys have any questions about this? This is the best example I had of really new media in my science, so. No. Yeah?
Could you give us a circumstance where the peer review process changed something that you were going to publish, the new open peer review process, how it might be different than had it been a closed one?
For me personally, well, I haven't yet submitted to this journal. And the reason is this journal is actually really new. So this particular paper, this 2006 paper, the reason it has the most comments is this was the first actual. I won't call it an issue, because the other thing with open access journals is they don't really have issues anymore because it's not a paper publication. But it does. So 2006 was basically the year that I think 2000, because this is December 2006, January 2007 was the first month that they actually started publishing things. So it's a young journal. It wasn't clear initially that this was going to take off. So the fact that it's 2014, so 7 years later, and it's kind of basically become a standard is probably a good thing. I think it's not clear that, like many things, it's not clear how much scientists are comfortable providing their data before publication. Because what this is, so one of the drawbacks, maybe I could ask you guys this, what would be one of the drawbacks of basically putting your data out there without it being published? Yeah. Yeah, exactly. So one of the things that, we collect a whole bunch of data, and we can't just say in a paper, this is all of our data. We have some interpretation that goes into it, usually some modeling or something like that. And so if we publish this paper, or we put this paper in this kind of format, in this kind of journal, and we just make it available, at this point, somebody who did not spend 2 years in the field eating, fried steak and chilies, it can take our data, and they could write a paper about our data right away. Essentially, they could take our, data and they could say, "Oh, I have a different interpretation that's better, so it will get published before your paper is actually published." And this is something that a lot of scientists are really afraid of, because one of the mandates that's coming from the National Science Foundation and NASA is that for every time we get funded now, we need to make all of our data available at the end of our grant. So within 3 years of 3 years of us collecting the data, we now need to make it available, regardless of publication. And so this is something that's, just as an aside, something that scares a lot of us if you can't keep up with getting it out there. Or, you have something like this where someone doesn't believe you so much that the review process takes a couple of months.
For specifically reviewing your data, do you hire somebody outside, or do you have somebody within your team that works to
The statistical analysis, I'm going to turn this off because I think this is done. Oh no, maybe not. Yeah, I don't know. Okay, so no, we do all of our statistical analysis ourselves. So sometimes